Hello everyone, welcome to lesson 11. In the previous lesson, we defined the transfer function g of s. Today we explore what happens when we apply a special input, the Dirac impulse, and how the system response leads to a general output formula through convolution. The Dirac impulse delta of t is a theoretical signal. It has infinite amplitude at time 0, 0 width, but its area equals 1. Think of it as an infinitely short, infinitely strong kick applied to the system. Its Laplace transform is simply 1. When we apply the Dirac impulse as input, the output is called the impulse response. We write g of t equals s of delta of t. The impulse response completely characterizes the system behavior, just like the transfer function does. Here is the crucial connection. The impulse response g of t and the transfer function g of s are a Laplace transform pair. Taking the Laplace transform of g of t gives g of s. This means the impulse response in time domain and the transfer function in Laplace domain contain exactly the same information. Now we answer a practical question. If we know the impulse response g of t, how do we compute the output for any arbitrary input u of t? The answer is convolution. The output y of t equals the convolution of g and u. Written as an integral, y of t equals the integral from minus infinity to plus infinity of g of t minus tau times u of tau d tau. This integral slides the impulse response over the input and sums the weighted contributions. In the Laplace domain, convolution becomes simple multiplication. Y of s equals g of s times u of s. This is exactly the transfer function relationship we learned in the previous lesson. Convolution in time equals multiplication in frequency. To find the actual time domain output, we take the inverse Laplace transform. Y of t equals the inverse Laplace of y of s, which equals the inverse Laplace of g of s times u of s. This three-step process, transform, multiply, inverse transform, is the standard method for computing system responses. Let us see an example. For a first-order lag with g of s equals k over 1 plus st, the impulse response is g of t equals k over t times e to the minus t over t. Applying a step input and using the multiplication rule, we get the familiar step response k times 1 minus e to the minus t over t. For a pure integrator, g of s equals 1 over s. The impulse response is g of t equals 1, a constant. Convolving a constant with any input gives the running integral of that input. This confirms that the integrator accumulates the input signal over time. Great work! In this lesson, we learned that the impulse response g of t fully characterizes a system that g of t and g of s are Laplace pairs, and that the output for any input can be found by convolution in time or multiplication in the Laplace domain. See you in the next lesson on step responses.